In the next examples, we're going to be looking at identifying angles from trig ratios. Okay, so it asks us to use the trig ratio that the cosine of A equals 24 over 25. Okay, and it asks us to use that to determine which angle of the triangle is angle A, or is A. Right, so we want to know basically, is this A or is this A? Okay, and we're going to try to figure that out using the fact that the cosine of A equals 24 over 25. Okay, so let's look at maybe, well, a couple things first here, I guess. So first of all, we have to understand that the cosine of A is going to be equal to the adjacent leg over hypotenuse. Right? Now remember, if you haven't memorized this yet, you're in big trouble. Okay, this is SOHCAHTOA. Right? And since we're using ka, right, for cosine, it's adjacent over hypotenuse. Okay? So again, the cosine of A equals the adjacent leg over the hypotenuse. All right, now let's just say, maybe I'll call this now the cosine of angle 1. Okay? Well, the cosine of angle 1, if angle 1 is the angle in question here, okay, well, the cosine of that, the adjacent leg here is 1.4 feet. Okay, so adjacent is going to be 1.4 over the hypotenuse, which is 5 feet. Okay, well, if I simplify this, I'm actually going to try to simplify the fraction because they gave us the fact that the cosine of A is 24 over 25. So I could multiply both sides by 10, or top and bottom by 10, which would give me 14 over 50. Okay, and then I know both those numbers are even, right? So I'm going to, I guess, divide both the top and the bottom by 2 here. So I know 14 divided by 2 is 7, and 50 divided by 2 is 25, right? Well, if I look at that, that doesn't, you know, the cosine of angle 1 is 7 over 25. That doesn't really work for us, okay? But let's, you know, check angle 2 and see if that works out. All right, so I'll look at, you know, the cosine of angle 2. So this is the angle in question. So again, cosine of angle 2. Well, the adjacent leg to angle 2 here is 4.8. So this is 4.8 over the hypotenuse, which is still 5. Okay. Well, again, I don't like these decimals, so I'm going to multiply both the top and the bottom by 10, which will give me 48 over 50. Right. Now, both those are even numbers, so if I divide both the top and the bottom by 2, that will give me 24 over 25. Right. And we should see this kind of match up here. Right. The cosine of angle 2 equaled what we have originally here. Right? And so at this point, we can maybe say something on the bottom. We can say, I don't know, some sort of statement that says that these match, right? So we can say, like, since the cosine of A equals the cosine of angle 2, you just say angle 2 is angle A, or A. Right, so this would be like our final ta-da statement after all of that work. Okay, let's go ahead and take a look at another example here. Okay, so on the next page. Okay, so we'll go ahead now and take a look at, you know, this one says use the given trig ratio to determine which angle is angle A, or which angle of the triangle is angle A. Okay, this one says sine of A is 8 over 17. Okay, so this is what we're going to use now. Okay, we're still going to remember SOHCAHTOA, right? And you're going to hear me say that a million times, and you'll probably make fun of me for it, but that's okay. I can handle it. Okay, and so again, this is what's in question this time, where we're thinking opposite over hypotenuse. So I'm going to say right away, I'm going to say the sine of A equals the opposite over hypotenuse. Okay, and so maybe I'll makes sense to look at maybe angle 1 first. Okay, so the opposite to angle 1 is, the opposite leg is 27. So I'll say the sine of angle 1 is 27 over the hypotenuse here, which is 30.6. Okay, again, just like the last example, I really don't like these decimals, so I'm going to multiply both the top and the bottom by 10, which will give me 270 over 306, right? And And again, now you can go through the process of reducing these. I'm gonna cheat here a little bit just to save some time. But 270 over 36, if we reduce those properly, is actually going to give us 15 over 17, right? Which doesn't really work for us. Okay. And so now at this point, I'm going to test angle 2, right? So I'll change colors here, and maybe I'll change to blue now. So I'm going to go ahead and erase this red up here so our picture is a little bit better. Okay, now look at the sine of angle 2, right? Well, if I'm looking at angle 2, the opposite leg to angle 2 is 14.4. So I'm going to write this as 14.4 over our hypotenuse, which is still 30.6. Okay, now again, I don't like these decimals, so I'm going to go ahead and multiply both the top and the bottom by 10, which will give me 144 over 306. And if you go ahead and reduce these, you'll end up with 8 over 17. And again, we have this moment where we say, okay, well, that actually matches the sine of angle A, which is 8 over 17. Okay, so we can make our final statement here, and we can say something like, since the sine of A equals the sine of angle 2, angle 2 is A. Right? So again, really not too bad. Okay, I think we can all handle those. Definitely try to get some examples in on your homework going through this stuff. But again, with a little bit of practice, this stuff really isn't too bad.